Alright, let's take a look at the circuit here. We have a circuit made up of a bunch of capacitors, and we're told to find the equivalent capacitance at terminals A, B. So the first thing we want to do is we want to write down the characteristics of capacitors in regards to capacitors in series as well as in parallel. Okay, so with regards to capacitors in series, okay, we want to remember that the equivalent capacitance is equal to C1 times C2 over C1 plus C2. Okay, so C1 times C2 over C1 plus C2. Now if you have more than one capacitor, then it's actually, we can rewrite it in the generic format or the general format of 1 over C equivalent is equal to 1 over C1 plus 1 over C2 and so on and so forth. Okay, the other thing we want to remember is in parallel, the relationship is to get C equivalent, it's just going to be the sum of the capacitors. So in this case, we'll just say C1 plus C2. So these guys are going to be key to putting this together. Okay, so we're going to use that property there. So if we look at, let's work from the right and we'll go backwards. So first thing here, I see I have this capacitor and this capacitor. So we have the 4 microfarad and the 12 microfarad capacitors. They're in series. Okay, so I'm going to go ahead and write this down. The 4 microfarad and 12 microfarad, these guys are in series. Okay, so all we have to do is use the equation on the right there, so we can say our C equivalent is going to equal 4 times 12 over 4 plus 12, and then if we compute that, that's going to give us 3 microfarads. Okay, so the combination of these two guys will give us 3 microfarads. I'm going to clean that up. Okay, so now we have 3 microfarads. However, that 3 microfarads along with these 3 microfarads, now these two are going to be in parallel. So let's go and write that down. So now the resulting capacitance, so we got 3 microfarad and the other 3 microfarad, these guys are going to be in parallel. Okay, so these guys are going to be in parallel now. Okay, so let's highlight that. So if we add those up, because the equation again tells us we add them up, if they're in parallel, we get 6. Our C equivalent in this case is going to be 3 plus 3, which is going to be 6 microfarad. Okay, so now I'm not redrawing it, but you can just try to visualize it. So this 3 and 3 is going to give us 6. That 6 microfarad is going to be in series with this 6 microfarad. So I'm going to go ahead and write this down here. So now we got 6 microfarad capacitance, which is going to be in series with the other 6 microfarad capacitance. So I'm going to go ahead and write that here. So we got 6 microfarad and 6 microfarad. These guys are going to be in series. Okay, and because they're in series, we can say our C equivalent is going to be 6 times 6 over 6 plus 6, which is going to be 36 over 12. which gives us 3 microfarads. Okay, so now we worked our way up. Now we're at this level here. So now we got 3 microfarads here. Alright, so that 3 microfarad right there is now going to be in parallel with the 2 microfarad. So I'm going to write that down. So we got 3 microfarads and 2 microfarads are in parallel. And just highlight that here. So all we have to do is add them up. So our C equivalent in this case is going to be 5 microfarad. And then finally we have 5 more microfarads. I'm going to write that down here. You got 5 microfarad with the other 5 microfarad, and they are in series. Okay, so let's see, do I have any other colors? Let's try orange. We got 5 and 5. Okay. Okay, 5 and 5 there. And they're in series, so I'm going to write that down here. 5 microfarad and 5 microfarad are in series. Okay, so we just say C equivalent is going to equal to 5 times 5 over 5 plus 5. So that's 25 over 10, which is going to give us 2.5. So we're going to get 2.5 microfarad as our final C equivalent. So this is going to be our final answer. Okay, so our C equivalent of this entire circuit is 2.5 microfarad. Okay, and like I said, essentially it's using these rules, the characteristics of capacitors in regards to them being in series as well as in parallel. Okay, and that's how you solve for this problem.